So welcome to the GATE lecture series on section 2, Network Signals and System. So myself is R.ASHWINI, working as an assistant professor in the department of ECE. So I am here to give a brief introduction about network theorem, in particular about superposition theorem, which will be very much useful for cracking GATE questions. So as we all know, network theorem. So before network theorem, we shall use Ohm's law and Kirchhoff's voltage and current law to solve any given circuit. Now what is the speciality of these network theorems? Network theorem are already derived from the basic laws like KCL and Ohm's law, and it gives an easier approach for solving theorems and circuits, any complicated circuit. And here is a list of network theorems like superposition, Thevenin's, Norton, Millman, maximum power transfer, star to delta and delta to star conversion. We are very much focused in superposition theorem, its application and the procedure to solve a given circuit using superposition theorem. So here is the definition for superposition theorem. See, actually superposition theorem can be applied to any circuit where there are more than two sources available. So if at all if any response through any of the branch is being asked to calculate, then at that point superposition theorem is the best choice. So as per the definition, we can say in any linear directional network having more than one independent source, the response in any of the element is equal to the algebraic sum of the response caused by the individual source, while rest of the sources are replaced by the internal resistance. So this is the important point to be noted here. So superposition theorem holds good for any circuit having one or more independent sources, and if any response like voltage or current is being asked to calculate from any branch or node, then this is the most appropriate technique. As we can see, the applications of superposition theorem, it is used in converting any circuit either into its Norton equivalent or Thevenin's equivalent. So superposition theorem will help us to modify a given circuit into either a Norton's equivalent or a Thevenin's equivalent circuit. And very specifically, GATE questions will be more biased to theoretical point also. So you have to be very clear with this theorem is applicable only to linear network consisting of passive devices like your resistor, inductor or capacitor, a linear transformer, dependent as well as independent sources. So one should be very much specific about the type of the network for which superposition theorem holds good. Coming to the steps for the solution of a network. So whenever we are in a motto of applying superposition theorem to a network, certain steps need to be followed. So coming to step number 1, when we have multiple number of sources, at any point of time, only one source alone can be taken into account. That is, one source can be made active, whereas the remaining sources has to be made operative, non-operative, which means it should be deactivated. Now, coming to the types of sources. So, usually, we will be dealing with two types of sources, namely, voltage source and current source. Voltage source and current source. So as you can see here, we have voltage source and current source. So whenever voltage source has to be deactivated, it should be short circuited. So which means this makes our voltage equivalent to 0. Coming to current source, whenever we want to make a current source to be non-operative, like this, when we have some 1 amps or 2 amps source and we want this to be 0, we have to make this as a open circuit. So open circuit current is equivalent to 0. So these two things are very, very important because we will be playing the game only with two sources, either a voltage source or a current source. If it is a voltage source, make it short circuit. If it is a current source, make it open circuit. Now coming to step number 2, you have to repeat the step for each of the independent source. So currently in the previous step we will take only one source active and remaining sources will be kept inactive, whereas in step number 2 we have to do the reverse process. Earlier it was active, now it should be inactive, and choose a new source which we have to make it active. Third one, to determine the net value of the variables like either current or voltage, you have to sum up the result obtained from step 2 as well as step 1. So these are the combined steps to be followed for solving any complex circuit using superposition theorem. And very important thing, next comes our limitation. So though we have very good advantages for superposition theorem, still there exists some limitation. So what are those limitations? As you can see, the first point, this theorem does not apply to non-linear circuits. So a non-linear circuit might not be that much applicable, or that superposition theorem might not hold good for a non-linear circuit. Now the reason is, with superposition theorem, we are able to calculate only the voltage and current value, but not power value. So superposition theorem does not be applied to find power. The reason is, power is actually a non-linear function that does not algebraically gets added to accurate total when only one source is considered at a time. So this is very important point to be noted, because the first limitation, whatever you have seen here, right? So this is the assertion. Why superposition theorem could not be applied to a nonlinear circuit? Because power is a nonlinear function which never gets added up algebraically when only one source is activated. So even in gate, people usually think of only numerical types of question will be occurring, but there are cases where theoretical point of questions will also be asked. So in that cases, you can expect more problems with this assertion and reason. So assertion is superposition cannot be applied to nonlinear. Reason is, since power is a nonlinear function, it cannot be added up algebraically when individual sources are acting up. So this is very, very important thing to be noted. Now based upon these steps and the basic understanding of the superposition theorem and its principle, let us see how to find the value or to find the response of a circuit. So here comes a simple problem. Find the value of the current Ix. So as you can see, Ix is the current flowing through the 2 ohm resistor. So using superposition principle, we have to find out the current Ix flowing through 2 ohms. See here, as per the procedure, as per the principles of superposition theorem, it is applicable only to linear circuit where more than 2 sources are available. So as you can see here, I have 2 sources. One is 10 volt source and another one is a 2 amp source. So a battery supply and a current source, right? Now step 1, since there are 2 independent sources, 10 volt and 2 amps, I am going to start reducing my circuit with only one source active, which is nothing but my 10 volt source. So I am keeping my 10 volt source active and I am going to deactivate my 2 amps current source. Now how to deactivate a current source? This can be done by open circuiting. This is what I have explained in the previous slide. So in order to make a current source to be non-operative or deactivating, it should be open circuited. So as we all know very well, current does not flow in an open circuited region. So current does not flow in the open circuited region. So the effect of this 3 ohm resistor becomes 0. There is no use of this 3 ohm resistor as this is connected to a open circuited region. Right now, we are very much confined with only this particular region, because this is a closed path where current can flow, and since this is open, current becomes 0. So effect of this 3 ohm is not at all taken into account. So this is a very simple circuit. We all know we have a 10 volt source, battery source, 2 resistor, 2 ohm and 2 ohm and 1 ohm, and we are supposed to find out the current flowing through the 2 ohm resistor. So just by making use of the very well known formula by Ohm's law, the current I by Ohm's law is nothing but V divided by R. Now what is V here? V is 10 ohm, V is 10 volt, R 2 and 1 are connected in series, so they are added up together, they are summed up together. So 2 plus 1 is 3, so this is 10 divided by 3. The current through this 2 ohm resistor due to this 10 volt source is only 3.33 amps. This is step number 1, considering only 10 volt source and leaving the 2 amps source. So step 1 solution is 3.33 amps. Now the second step has to be done, because earlier we used only 10 volt source, neglecting the 2 amp source, right? Now the same reversal should be done. 2 amp source is active and we are making the 10 volt source to be inactive. So as we all know very well, voltage source can be inactive or voltage source can be marked inactive by short circuiting it. So earlier you have a 10 volt source here, now I am short circuiting it so that its effects becomes negligible. Now here we have again a simple circuitry with current source, some resistors connected, right? Now one must understand, just by looking at the circuit, one must be able to understand what are the reduction techniques that can be used, since we have seen so many number of reduction techniques like Ohm's law, current division, voltage division, KVL, writing nodal equation, writing mesh equations, just converting a star into delta, right? So we have so many options, but it is our idea, it is our objective, right? So we have to find out a suitable technique which gives a result in a very crisp and short method. So I am supposed to find out this current Ix flowing through 2 ohm resistor, right? Now because of this short circuit, from our earlier understanding of the networks theorems and basic, it is very clear this one and this 2 ohm resistor are parallel to each other. So earlier in our discussion, you would have studied series parallel combinations, right? How to reduce a series network into parallel network, how to reduce a complex resistor network by series parallel reduction. So with that understanding, right, with that knowledge, I came to know this 2 and 1 are parallel to each other, and since I have a 2 amp source, this is nothing but a current division method. So using current division method, one can easily find out what is the amount of current flowing through any of the parallel branches, right? So it is very, very clear 2 and 1 are parallel branches. So we are able to find out the current flowing through any of the parallel branch by making use of current division method. So using current division method, the formula goes like this: current through 2 ohm resistor is equal to the total current 2 into opposite branch of this 2 ohm, that is opposite parallel branch of this 2 ohm is nothing but 1 divided by sum of parallel resistors. So here the sum of parallel resistors are 1 and 2. So on simplification, the current through the 2 ohm resistor due to this 2 amp source is simply 2 by 3 amps. So this is the amount of current flowing through the 2 ohm resistor because of 2 amp source. So right now we have completed step number 1, that is the amount of current through 2 ohm resistor because of 10 volt source. Step number 2, current flowing through the 2 ohm resistor because of 2 amps current source. Now last step is we have to sum up the results obtained from step 1 and step 2. So step 1 current, it is 10 by 3. Step 2 current is 2 by 3. Just now we have found it out. So summing up, the current is equivalent to 4 amps. So this is the total current flowing through 2 amp with this 2 ohm resistor due to superposition theorem. Right? Now one may ask a question: is this the only way to solve the given network? This is the only method to find out the amount of current flowing through 2 ohm? Definitely not. We have so many number of procedures. We have so many methods to identify either current or voltage, right? But why we are very specific about superposition theorem? What actually superposition theorem is trying to tell here? See, in general, if anyone is interested in finding voltage across any branch or current across any, right, it is very simple. We can go for any number of methods as we have studied. But if a question is very specific about, check what is the contribution of a particular independent source towards the finding the current value, towards finding the voltage value, then at that point superposition theorem seems to be the best one. So here also rather than seeing what is the current flowing through 2 amps due to the superposition theorem, your question or your understanding should be in this way: how much contribution my 10-volt source is doing to this 2 ohms, that is how much contribution is this making, right, for the current flowing through the 2 ohm resistor. As you can say, because of 10 volt, contribution is 10 by 3 amps. This is the contribution made by this 10 volt source, whereas the contribution made by this current source is only 2 by 3 amps. So if at all a question goes in this direction, finding the contribution, finding the individual responsible of the individual sources, then superposition theorem seems to be the best method. So this is the answer, and I hope this video finds you good. Next, coming to the next one, here is also a simple, as you can see, this is a very simple network where we are supposed to find out current I flowing through this 8 ohm resistor, right? So just by looking at the circuit, one can easily say what is the purpose of the superposition theorem in finding this current. I can go for writing KVL, I can go for KCL. Yeah, we have, there is nothing hard rules here, but we have to see what is the contribution made by this 16 volt battery, this 4 amps current source, and this 12 volt battery supply. So if we have such an understanding, then superposition theorem is very much understood. So as you can see here, out of 3 sources, initially I am taking only 16 volt source as active. So because of 16 volt source, my current source is getting open circuited and another 12 volt source is getting short circuited. So those differences you can very well see. See here, this is actually open circuited and this is actually short circuited. I am keeping only 16 volt active and making others inactive. Now your circuit becomes very simple with only 3 resistors connected in series and with a 16 volts battery. Now what could be the current? By Ohm's law, very simple, current I is equal to voltage V is 16 and this resistance R is nothing but the sum of 6 plus 2 plus 8, because all the resistors are connected in series. So the answer is 1 amps. So because of 16 volt, only 1 amps current is flowing through 8 ohm resistor. Coming to the next step, I am going to make this 4 amp source as active. So I hope this is clear. Out of 3 independent sources, only 4 amp source is active now. So I am making both the voltage sources as short circuit on either side of the diagram in order to make it inactivate. Again, this is a very simple circuit. See, this combination is a current source. Always a current source will have a resistor connected in parallel, right? So simply I am here using conversion, voltage to current conversion or current to voltage conversion formula. No equation, nothing, right? Very simple. So I am simply converting this current source 4 amps in series with this 2 ohm resistor into a voltage source with 8 volts and 2 ohm connected in series. This everyone is well known, right? So now this becomes a very simple series circuit. All the resistors are connected in series, 6 plus 2 plus 8. Current is I equal to 8 by 16. So the current here is 0.5 amps. So I1 is 1, I2 is 0.5. Coming to step number 3. Step number 3, 12 volt source is active. So here this particular current source, right? This particular current source is made inactive by open circuiting it. Voltage source is short circuited. This is current source 4 amps is open circuited, 16 volt is short circuited, and your 12 volt alone is active now. Again, this becomes a very simple series circuit. As you can see, 6 to 8 all are connected in series with sums up to give the value of 16, and by Ohm's law, current I is equal to minus 12 by 16. The reason why this minus is the directions of this are opposite to each other. That is the reason we have introduced a negative sign. So on simplification, the value of current is found to be minus 3 by 4. Now what is the net value? According to superposition theorem, the algebraic sum of all the current due to individual sources will get added up. So it is 1 plus 1 by 2, that is from step 2, minus 3 by 4 from step 3. So the summation or on simplification, this is the actual value of current flowing through the 8 ohm resistor. Right? Now on the other side, I have also given an introduction to power calculation. Actually I have given you that power is a nonlinear quantity which superposition theorem we cannot solve, but anyhow let us check how superposition theorem is not supporting this. So since we have 3 different current due to individual sources, 3 different powers can be calculated using the formula I square R. So this is due to source 1, power 2 is due to source 2, and power P3 is due to source 3. Right? Now each one is giving some value of power, 8 watt, 2 watt and 4.5 watts. Now what is the total power? This is the power due to source contribution 1, second source contribution and third source contribution 14.5. Right? But is this correct? Is this correct? Definitely not. This is actually a wrong procedure because power never gets algebraically added up. So this is where the limitation. So we need to check how this limitation can be understood. So this is the place where I have to call it as assertion and reason. Assertion, reason. This is wrong because power never gets added up algebraically. So I am going to leave this as a topic for your understanding. So kindly check why this particular thing does not holds good. So I find this video gives a better understanding of the superposition theorem. So we'll meet in the next series of videos. Thank you.